So if I give you this system, and I tell you first solve for p, the first thing I'd like you to notice is that this is separable, so that I could just write from this, I could just write 1 over p dp equals to negative lambda a plus lambda c dt, and I could just take the integral. That part is a constant, so I leave it out, and I can take the integral. Now, this will be ln of the absolute value of p, and that's going to be equal to negative lambda a plus lambda c times t. Now, if I exponentiate both sides of this, I get, so natural logarithm tells you the number that I need to raise e to get to the argument, in this case p. So what number do I need to raise e to get to p? ln of p. And so this becomes just p. And here this becomes this right here. So now, all we want to do is we want to put in the actual values in. And this is part A. So what is this going to be? Well, we have e to the negative. We want to do 4 point, let me see. We want to do 0.581 plus 4.962 times 10 to the negative 10 times t. So let's do that real quick. 0.581 plus 4.962. That's going to be the same thing as e to the negative 5.543 times 10 to the negative 10 times t. And now we have answered A. Well, not completely. Because if we integrate this, this is going to be plus c. Now, this times c can just be defined as another constant, so we'll still define it as plus c. So here we'll have a plus c. We'll have a plus c here. And that's going to mean that here we'll have an e to the c. But we can rewrite this. We'll say that this is p naught. So that's the initial value. So we can say that p is equal to p naught times e to the negative 5.5430 times 10 to the negative 10. All of that multiplied times t. Now, what do we want to do? Well, and this step right here really comes from p of 0 is equal to p naught, which means that you get p naught if you input 0 into this expression, which is this times 10 to the negative 10 times t, but now our t is 0, which makes this whole thing 1, which means that e to the c is equal to p naught, our initial value. So now that we have this, we want to determine the half-life. So I want to have half of what I originally had for a certain value of t. So you notice that the p's cancel out, and you get that 1/2 is equal to e to the negative 5.5430 times 10 to the negative 10 times t. Now, if I take the logarithm natural on both sides, I get 1/2. But remember, the logarithm tells me the power that I need to raise e to get to the argument. What power do you need to raise e to get to e to the negative 5.5430 times 10 to the negative 10 times t? Well, that power. So that is 5.5430 times 10 to the negative 10 times t. So you can solve for t now by having this 5.430 times 10 to the negative 10. And if you do that, let's see. Logarithm of 0.5 divided by negative. See, here I made a mistake because this was a parenthesis. This was a 5. So minus 5.5430 times 10 to the negative 10 right here. And we get 1.2505 times 10 to the 9 years, because this was in years. This was part B. So this is, let me make it a little bit clearer. This is part B. So we did part A and part B. Now, use P of t to find A of t and C of t. Well, so now we have part C. We know dA dt is equal to lambda AP, right?